relative humidity chart, it's the same thing as the video you previously watched, which was the dew point chart. So, same processes, same setup, same everything. The only thing that's different, if we flash back to dew point told us the temperature that clouds will form, the temperature that condensation happens. Humidity does the exact same thing for the same data, and instead it just gives you the number of how full is the air. Okay, so a side example, if you have two containers, okay, with my art skills, you got two drinks, okay, two coffee cups. This cup is filled this much, this cup is filled this much. It's easy, they're the same size cup. This one's about 75% full, okay, this one's about 40% full. That's easy, okay. The problem is a small cup, like a little Dixie cup or something. Well, you fill that whole thing full. This is 100% full, right? 100% full. It just didn't have very much capacity. A big cup, this has more liquid in it, but it's less full because it's a bigger cup. So this is like warm air, and this is like cool air. So that's why if you cool air off, it can hold less water and you'll make rain happen. Okay? So to figure out how full is the air, use this chart. Same exact setup. So if we use, you're going to get the numbers the exact same way. If the air temperature is 24, okay, degrees, and the wet bulb is 20 degrees C, you go to 24, your difference here is 4, so you'd go over to 4, you go down. Now instead of getting a temperature back, you get a percentage back. The air is 69% full. Okay? I would read this information. I would read this information. Clouds, 100% full. Let's do a couple practice questions. Parcel of air. What the heck are they talking about, a parcel? This just means air. It's a phrase that they use, confuses people. It's air. So the dry bulb is 16. Pause. Get my relative humidity chart, circle 16. A wet bulb is 13. Pause. That means my difference is 3. So I come up here, 3. %, full. 71% full. Oh, that was easy. Okay. Now, sometimes you'll have to go backwards. They could give you information in a bunch of different ways. Sometimes they'll ask you for the dew point and the relative humidity. You just need to use both charts. Okay? Sometimes you can work backwards and they will give you the relative humidity and ask you what the dew point is. Okay, let's do number 9 to see if we can work backwards. So the air temperature is 0. The humidity is 81. So, working backwards, they gave us this. They didn't give us the wet bulb. They gave us the humidity as this. Okay, so now we have to figure out what is the wet bulb. Well, if our difference is 1 and the temperature is 0, the wet is always colder, so the wet bulb would have to be -1 degrees C. If you don't understand that, rewind and start back. We worked backwards. They gave us this, they gave us this. We got the difference. We know the difference is cooler. They want to know what the dew point is. Okay, well, we've got to get out our other chart. They gave us this. They gave us this. Our dew point is 3 below. Sometimes you'll have to work backwards with the charts like that. You can go backwards and forwards from the charts. They're set up the exact same way. Okay? One of the things, sometimes you'll see these things in graphs. Okay? The relative humidity, the higher the relative humidity, the more likely it is to rain. Okay? When the humidity gets lower, it's less likely to rain. So you can kind of see that relationship. When the temperature gets higher, that makes the humidity get lower. Because when the temperature gets higher, it's like making the cup bigger and it can hold more liquid. So, one last thing to go through that. If you have a Dixie cup that's 100% full of liquid, okay, it's like cold air. If you heat the air up, you make that water go into a bigger cup. Now it's a lot more full, or a lot less full. So now you just took that same amount of water and you made it less humid.